Good evening, fellow scholars. My name is Faith Bratton, and I'm doing my Math for Teachers 2, Module 2, Lesson Chapter 9 with geometric figures. Okay, so get this started. Okay, this is lines 1 and lines L2 are parallel lines. Determine the measures of angle 1 through angle 12. Okay, so we know for the first one, we need to find angle 7. Okay, so to find each measure, begin by finding the measure of all the interior angles. We know that for a triangle, the sum of the interior angles are 180. We will use this to find angle 7. Okay, so angle 7, let me get a little, okay, here we go. So we know that we're first trying to find angle 7 to start us off because we need to find the rest of this triangle right here. And we know that a triangle always equals 180. Okay, to find angle 7, we know that we will subtract the two numbers, or we'll add up the two numbers that we have, which is 61 and 63, and we will subtract them by 180. Okay, so we have 180 minus angle 63 minus angle 61, and we get 56. So angle 7 is 56. Okay, let me get rid of my small line. Okay, next we need to start with angle 1. Okay, so we see angle 1 is right here. Notice that angle 7 shown as 56 and angle 1 are corresponding angles. Corresponding angles are always equal. So since we know that 56 is 7 and they're corresponding, angle 1 will also be 56. Okay. To find measure 2 or angle 2, we use the opposite of angle 2 with the value of 63. Okay, as we can see, the opposite of 2 is 63 from the triangle. So it's a vertical angle with angle 2. And since vertical angles are also equal, you know that angle 2 is 63. Okay, to find angle 3, notice that the bottom left angle of the triangle, shown as angle 61 degrees, and angle 3 are corresponding angles. As we were told with the first one, corresponding angles are equal. So 61 and angle 3 both equal the same. Okay, next we have angle 4. The angle of 4 is opposite with angle 4 with the value of 61. So here, the opposite is 61. So that just shows that the vertical angle is also 61. Okay, so next we have angle 5. The angle opposite of angle 5 with a value of 56 is a vertical angle. With angle 5, we know that the vertical angles are equal, so angle 5 equals 56. Right here given. Okay, so next we find angle 6. The angle on the right side of angle 6 is 61. It is a supplementary angle with angle 6. Supplementary angles have a sum of 180. So then we know that we have to subtract 180 minus 61 to find the value of 6, which is 119. Since we've already found 7, which was 56, we'll move on to 8. The angle of the left side of angle 8 with a value of 56, which is right here, 7, we know that is a supplementary angle just like angle 6 was. So we know that we must subtract 180 minus 56, which is 124. So that means angle 8 equals 124 degrees. Next we have find angle 9. The angle opposite of angle 9 with a value of 61 is a vertical. Okay, so since we know that, the vertical angle with angle 10, and since vertical angles are equal, we know that 10 equals 119. Okay, next we know that, so we know that 10 equals 119. Or angle 9 equals 61, my bad. Okay, so now we know that find angle 10 is the opposite, so we know that the value is 119. Okay, it's a vertical angle, and since angle 10 and number 6 are vertical angles, we know that they equal the same, so it's 119. Okay. To find angle 11, we have the opposite of angle 11, which is 124. It is a vertical angle with angle 11, and since vertical angles are equal, we know that angle 11 equals 124. Okay, to find vertical angle 12, we look at the opposite of angle 12 with the value of 56, which is a vertical angle with 12. 7 and 12 are vertical angles. So since 7 equals 56, 12 equals 56. Okay, question 2, it says demonstrate to find the measure. Let PQ and AB and RQ and AC find the measures of angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. Okay. So we're going to let PQ and AB and RQ and AC be together. So we start by finding the measure of angle 1. There are two angles whose measures are known, angle B and angle C. So we notice that angle 1 and angle B and angle C are the three angles in the triangle ABC. The sum of the angles in the triangle equals 180. So the whole triangle will equal 180. So we have the two given, 74 and 26 degrees, and we must find one, which is 8. Okay, so the sum of the measures of angle 1, angle B, and angle C is 180. So we'll follow the measure of angle 1. Okay, so we're going to use this formula, m angle 1 plus m angle B plus m angle C equals 180. So we're going to sub in what we have. So m angle 1, since that's what we're trying to find, plus 26 plus 74 equals 180. So then when you add those two up, you get a certain amount, and then you get 100. Then you subtract 100 by 180, and you get 80 degrees. So you know that m1 equals 80. Okay, for the next one, if you extend the parallel lines, which we did right here, you know this will help to identify the corresponding angles. From the figure, angle 3 and angle 8, which are these two right here, we know that they are corresponding angles to angle 1. So measures of angle 3 and angle 8 are also 80. Okay. So next we have to find angle 2 and angle 3. They are adjacent angles that form a straight angle. They are supplementary, so the sum of the measures of the supplementary angle is 180. To find the measurement of angle 2, we use this formula given. M angle 2 plus M angle 3 equals 180. So we know we have 3, which is right here, which is 80, so we'll plug in what we have. So we know that 80 into, or M angle 2 plus 80 equals 180. So then we subtract 80 by 180, and we get 100. So M2 equals 100. Okay, so we notice that angle 5 and angle 3 are alternate interior angles. Okay, so since angle 5 is congruent to 1, 3, and 8 angles, therefore the measure of angle 5 is also 80. Okay, to find angles 7 and 8, they are adjacent angles that form a straight angle. Therefore, they are supplementary. So angle 7 and angle 2 are both supplementary to angle 5. The measure of angle 7 is the same as the measure of 2, or 100%. Only angles whose measurements are not yet known are angles 4 and 6, as we can see right here and right here. Consider BC, which is B and C, this straight line right here, as a transverse to the parallel lines AB and PQ. Based on our diagram, angle 4 and angle B are corresponding angles. So B and angle 4 are congruent. So the measure of 4 is 26. Finally, consider BC right here as a transversal to the parallel lines AC and RQ. Angle 6 and angle C are corresponding angles, so they are congruent and their measures are the same. So angle 6 equals 74. Okay, this is a diagram of what you can use to figure it out. And another way you can check this image of the two triangles, or each triangle has to equal 180. So add like 26 plus 80 plus 106. You do 180 minus 106 equals 74. So angle 6 could be 74. That's another way. This is the diagram, a little chart that shows us the angle 1, which is given right here, equals 80 degrees. 2 equals 100, 3 equals 80, 4 equals 26, 5 equals 80, and so on. Okay, question 3 is construct the concave polygon. Demonstrate how to find the measurements of the angles in the concave polygon. Okay, so first we're going to substitute the value of y into the expression for each value. We're going to start with n equals 3, but we'll do that in a second. Okay, to construct this, we need to find the sum of the measures of the interior angles of any n gone is n minus 2 times 180 degrees, where n is the number of sides. But first, we need to know what the number of sides is. So we need to take the concave polygon, and we need to add up the sides. So we know that, here, let me just draw this. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we know that there are number of sides equals 8. Okay, and we were given that equation. Okay, so now we can substitute n into the equation. So we get n minus 2 times 180. So we go 8 minus 2, because we sub in n equals 8, which is the number of sides. N minus 2 times 180. So we get 8 minus 2 is 6 times 180. We get 1,080. Next, sum the number of the measurements for the interior angles equal to the value of the sum of the measures of the interior angles and solve for y. So what we're going to do is we're going to add up each one. So we have, let me get my little notation back, my little laser. Okay, so we have 3y plus 12y. Where did that go? Hold on 1 second. Okay, so we have 3y plus 12y plus 3y plus 7y plus 7y plus 7y plus 3y plus 12y, which is 180. 1,080. Okay. 1,080 was a total from here, and so we have to add all these up, which is 54y. But we're solving for y, so we must have to divide both sides by 54, and we get both sides 54, so we get y equals 20. Okay, for next, we have to substitute. We substitute the value of y into the expression. Okay, so we'll start with n 3y. So we'll substitute the 20% that we just got from the previous question, y equals 20, and we'll sub it in. So we go, since we have 3y right here, we sub it in. So 3 times 20 equals 60, so m angle 3y equals 60. Now we'll do 7 because it's the next one. 7 times 20 degrees equals 140, so m7 equals 140. Now we'll do 12. 12 times 20 degrees equals 240, so m12 equals 240. And that's the total of each one. Okay, now we're going to construct the regular n-gon shown to the right for question 4. Demonstrate how to find the measures of the interior, exterior, and central angles. In a regular n-gon, each interior angle has a measure of n minus 2 times 180 divided by n. Each exterior angle has a measure of 360 degrees divided by n, and each central angle has a measure of 360 degrees divided by n. First, determine the value of n minus 9. Okay, so to determine the value of n minus 9, we find this by adding up the sides. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let me delete this from the first one. with me for a second. Okay. Substitute n equals 9 into the formula of the interior, exterior, and central angles into this equation, n minus 2 times 180 degrees divided by n. So we substitute 9 in, and we come up getting 1,260 divided by 9, which is 140 degrees. Okay. Now substitute n equals 9 into the formula for the exterior angle, which is 360 divided by n. Okay, 360 divided by 9 equals 40 degrees. And that is for the interior, or the exterior and central. The central and exterior are both 360 degrees divided by n. Okay, thus the measure of each interior angle is 140. The measure of each exterior and central angle is 40 degrees. For question 5, reconstruct 3 of the faces of the tetrahedron DEGH as subsets of the faces of the cube, which means that the tetrahedron inscribed in the cube has none of its faces in the planes of the face of the cube. So first we're going to trace the cube, which I have done already, and then we have to identify which place is what. So this is A, we have B, C, D, E, G, H, and F. Okay. For the first one, we're going to know that a tetrahedron, and since it's not going to let me end my PowerPoint presentation to show you about this. Okay, here we go. If we go to this, it's going to let me. Why is it not showing me this one? Okay, here we go. This is going to show the tetrahedron and how we can move it. A tetrahedron is 4 equilateral triangles. As we can see, they're all the same, no matter what. The base even counts. They're all the same length, and they're all equilateral. Okay, let me go back to my slideshow now. I just want to show you how I can move that around. Okay, here we go. Okay, so first we have to add or trace in a tetrahedron triangle into this. Okay, so first we're going to do D to E, E to G, G to D, and then D to H and G to H to show the tetrahedron model, which is right here, in 4 equilateral triangles inside the cube. Okay, 3 of the faces of the tetrahedron E, or DEGH, are subsets of the faces of the cube. Next, we find a tetrahedron inscribed in the cube that has none of its faces in the planes of the face, which is right there. Okay. For question 6, we must know what a tetrahedron, an octahedron, and an isohedron is. Okay, a tetrahedron is the first one right here, the red, blue, and white. A tetrahedron is a polyhedron that is also identified as a pyramid. It is made up of 4 equilateral triangles. All the sides are equal, and there are 4 vertices on the triangle. The next is an octahedron. It's like a tetrahedron, but it's 2 put together, like one on top, one on the bottom. It has 8 face figures. It's an 8-face figure. It has 6 vertices and 12 edges. The isohedron is a 20-face figure, as you can see, that is an equilateral triangle that is convex and has 30 edges with 20 vertices. And those are the differences between a tetrahedron, a octahedron, and a isohedron. Okay, thank you for listening to me in my listen. I hope you've learned something like I did, and so I hope you enjoyed.